So let's read the question together. Sodium hydroxide with the formula NaOH and hydrochloric acid with the formula HCl can react together to make sodium chloride NaCl and water H2O. Describe the method used to find the exact volume of sodium hydroxide that reacts with 25.0 cubic centimetres of hydrochloric acid. So what's the command word? The command word is describe. Then what other things do I need to be aware of? I'm wanting to write a method. And remember, a method is a step-by-step approach to how to do a practical. And I'm writing a method to find the exact volume of sodium hydroxide that reacts exactly with 25 cubic centimetres of hydrochloric acid. Now this question is the one where you are judged on your quality of written communication. And what the examiners are looking for is a flow, a logical flow of the information. So we're writing a method. We want it to be step by step and we want it to be chronological. So at the start I do this, then I do that, then I do the next thing. What you don't want is it to be all over the place. At the start do this, at the end do that, then back to the start. So to help us order our thoughts, it's worth us writing a quick plan. Now, I write a plan usually in pencil on my exam paper, so it's clear that it's something different to my main bit of work. So, reading the question again, I'm doing a method to find the exact volume of sodium hydroxide. What do I need to use? And it's a technique called titration. So I'm going to write that down to act as an aid memoir. Now, in a titration, you're going to have a burette with a liquid in it, and you're going to have a liquid in a conical flask, and you're going to run the liquid from the burette into the conical flask. So which liquid am I going to put in the burette? I'm going to choose HCl to be in the burette, as it runs very freely through the tap. I could use sodium hydroxide, but the problem is that it tends to make like a white powder that blocks up the tap. So for practical reasons, it's better that HCl would be in the burette. So therefore, sodium hydroxide will be in the conical flask. Now, in order to monitor the reaction, I'm going to have to add an indicator. I could use a pH probe, but that's less likely. Now, I could give a little bit more information here and actually say which indicator, for example, phenolphthalein or methyl orange, but keep it very upbeat and simple, and then you're less likely to do yourself out of marks. A lot of students feel that they want to put universal indicator down. This is something that we would never use in a titration. That's because it goes through a range of colours. So it's really difficult to decide when the indicator has changed colour in order to indicate that the reaction is complete. Whereas if you use an indicator like phenolphthalein or methyl orange, there are only two colours, so you can be far more sure when that end point, the colour change has happened. And then I've got to pause and think about, well, what information am I going to be collecting? What I actually want is the titer. That is the posh word really for what volume of liquid you've added from the burette. So I'm ready to go now, and I'm ready to write my method. And so I go back to my normal pen that I'm writing with. What am I going to do? I'm going to fill my burette with my acid, HCl. And then I'm going to use a measuring cylinder to measure exactly 25 cubic centimetres of sodium hydroxide into a conical flask. Now, I could also use a 25.0 cubic centimetre burette to measure it, but in this case, a measuring cylinder is absolutely fine. I'm going to add a few drops of indicator to the conical flask. And then I'm going to put the conical flask on a white tile under the burette. Now, the reason why we use a white tile is so that you can see the colour changes more easily. So that is quite an important important thing, and this actually is historically why chemists wear white coats, because back in the day when you were doing your observations, you might lift up your test tube and you hold your sleeve at arm's length and put the test tube in front of it, and of course your sleeve is white, and that allows you to see the colours more easily for your observations. So now I've got the setup, I'm ready to start, but let's not forget to note the starting volume on the burette. So I've phrased that we are reading, so that's actually reading it off the piece of equipment, and we're recording it, and we record this in a results table. Then what we're going to do is open the tap of the burette and add the hydrochloric acid to the conical flask, and we're going to swirl the mixture and observe. And then we're going to stop the tap when the indicator has changed colour. And then we need to reread and record the ending volume. So we're going to read and record the ending volume or final volume on the burette. Then we're going to calculate the titer, which if you wanted to, you could explain that in a little bit more detail, which is the end volume minus the start volume. Okay, and then you need to repeat until you have two concordant results, or you could phrase that as titers. And that's so that you can measure an average titer. Now, concordant is usually between 0.1 cubic centimetres, two values that are within 0.1 cubic centimetres of each other. And that would show that you've been reliable in your experiment.